Yeah, well, hey everyone. Thanks for being here today and thanks for having me speak. My name's Joe and I'm a Google developer expert for Android. And I'm here to talk to you today about using Compose inside of your existing Android apps. So there'll be some time for questions at the end, but you'll find my Twitter handle on each slide if you want to reach out on Twitter also. Cool. So when it comes to composing our apps, we're likely going to see one of two cases. So we're either going to be creating brand new features with Compose, so building Compose only screens, or we might be slotting Compose into existing features of our app, or even using the Android UI toolkit inside of those Compose screens. So in many cases, a lot of developers will be taking this approach and introducing Compose into existing apps. In these scenarios, as tempting as it might be, it's unlikely that we're going to be rewriting every single screen from the Android UI toolkit to Jetpack Compose. There will be certain things that might become blockers or road bumps during that process. And while every approach is different, company focus, team size, any current projects, or so on, there are a couple of things that could actually make the incremental adoption a requirement. So to start with, there's still a bit of a learning curve with Compose when compared to how we are used to building Android UI. So being a completely different way of building UI components that also heavily relies on the architecture of the app, such as state management. There's a lot for teams to adjust to and then also work out how this fits into their projects. So while Compose adoption will help us move faster in the long run, we still need to deliver value to our users in the meantime. So dropping everything to adopt Compose might not be a practical approach for most teams, but being able to do so incrementally allows us to do so while still delivering this value. Here, it's all about being strategic about how we can move forward with Compose and then still get that value to our users during our adoption. And then also some things just aren't ready or maybe aren't available for us to use in Compose yet. So meaning we'll have to take a hybrid approach and fall back to the Android UI toolkit where it is required. And finally, we might have existing views that are not quite in a position to be converted to Compose yet. So this could be for any reason. Maybe a view is quite complex and would require a large amount of work to migrate. That the work involved in that migration might not be the best use of our time right now. So we're going to need to find ways to work around that and still be able to move forward with Compose. So at the end of the day, there could be a number of reasons why, but being able to support a hybrid migration is a key feature of Compose that allows teams to move forward with Compose adoption while still being able to deliver value to our users. This unblocks us from using Compose while still allowing us to circle back in future and tackle these parts of our app whenever the time is appropriate. Now, in a lot of apps, we're going to end up using composables inside of the Android UI toolkit, as well as the Android UI toolkit inside of composables. So knowing about the tools that we have at our disposal are going to help us achieve these things smoothly. So we're going to start by looking at how we can use composables inside of our existing Android layouts. This can be achieved with what is known as the Compose view. So the Compose view is an Android view class located inside of the Compose UI platform package. At a first glance, this looks just like any other view that we might come across when working within the Android UI toolkit. This class extends from another class which is known as the abstract Compose view, which we'll come on to a bit later in this talk. The extended class handles all of the complexities of this view, with a Compose view simply exposing a set content function which can be used to assign a composable to this view. So with that said, Compose view is essentially a view that we can use to display composables inside of the Android UI toolkit. The great thing is that because this is just another view, we can pretty much use it in a similar way to which we have been using existing views inside of our apps. So under the hood, the Compose view utilizes the lifecycle of the parent class so that composition can be tied to the lifecycle of that class. So for example, this allows for disposal of composition as required, essentially tearing down the view when needed. So as I mentioned, the Compose view is pretty much like any other Android view that we might currently be using in our apps. This means that we can add this view to our XML layout like so. Because of the nature of this view, as in it's used to display composable UI, there are no custom attributes that can be used to control anything around the composables inside of this view. So by adding this to an XML layout, we are essentially adding an empty placeholder, which acts as a holder for composables. So instead, a composable needs to be applied programmatically using the setContent function of the compose view. So as we can see, when we call this setContent function here, we pass a composable into that function, and then that composable will be composed inside of our compose view and displayed within our UI. So here we've added a compose view to our XML layout, and we've got a composable now showing inside of an Android UI Toolkit class, which is pretty cool to see. So while working with XML layouts is fairly common inside of Android apps, it might not always be the case that we want to place a compose view in this kind of location. In other scenarios, we can add the compose view programmatically, just like we would do with any existing Android view class. So here, the behavior and configuration of the compose view would then remain exactly the same as when added via an XML layout. So we can use the setContent function to assign a composable to the compose view, and being able to do this programmatically opens up opportunities in other parts of our code base too. So for example, outside of adding the compose view to an existing layout, we might want to do something such as returning it as a layout view from the onCreate function of a fragment. So this is essentially using the compose view as the layout of the fragment that's being used on screen. So this saves us inflating an XML layout, and we can, for example, maybe you're heavily invested in the navigation component with fragments. This allows you to keep that navigation stuff in place, migrate to compose inside of your UI, and then tackle the navigation at a later stage. So in your app, it might be the case that you end up using multiple compose views within the same layout. In these cases, you'll need to assign a unique ID for each one in order for saved instance state to work as expected. So this can be achieved by defining IDs within an ID resource file, and then using these IDs to assign an ID to each of the compose view instances. Doing so will help you to ensure that save instance state works as expected for your screen. So as we can see from the previous examples, the compose view empowers us to add composables to existing Android UI Toolkit layouts, both programmatically or via XML. So in a nutshell, this view is essentially going to be used anytime you want to use a composable inside of an existing Android view class. So while that statement outlines a clear scenario, this can look different depending on the project and the team. So let's try to visualize some of these things. So maybe you're building a new feature, or even adding an existing feature, and you want to use compose inside of an existing layout. Maybe your team is learning compose and you want to tackle smaller and simpler parts of the UI before diving deeper into larger migrations. Maybe you are working with a complex UI and want to incrementally migrate an existing layout to compose. Or maybe a component in your UI is not yet supported by compose, or there are issues that are introduced when doing so. So these are just a few scenarios that come to mind. They all essentially link to the same outcome, being able to incrementally migrate compose inside of existing Android layouts. So now that we've got a better idea of what the compose view can be used for, there are likely going to be times when we need further support for composables inside of existing Android classes. For this, we have the abstract compose view class. So for example, while the compose view allows us to achieve the goal of inserting composables into existing Android layouts, there may also be times when we want to smoothly share custom Android view classes or even composable functions across different parts of our app. Things could also start to get a little complex when we try to work with other parts of Compose, such as state, maybe more complex composables, or even views that contain a lot of configurable information. In these cases, it might make more sense for us to extend from the abstract compose view class ourselves instead of relying on the provided compose view implementation. So for example's sake, let's start with a minimal implementation of the abstract compose view. So at this point, we've extended from the abstract compose view, we've overridden the provided content function and provided a simple text composable. There's one problem here though. We don't have any content to provide for that text composable. And we don't have any way for an external class to provide a value for that text. In these cases, we're going to need an internal variable reference that can be manipulated and used to control the content of our composable. So here, we implement the text property of our view as mutable state. This means that our custom view can still be inflated and placed inside of existing layouts, but this time offering the ability to support some form of internal state. It's best practice in these scenarios to utilize mutable state of objects to ensure that the property is kept thread safe for Compose. So with this in place, this can then be manipulated from our Android class, just like any other view class or binding. The use of this mutable state will ensure that recomposition will reflect any state changes for our custom view. So at this point, though, what is really the difference from when we were using the Compose view? Like, couldn't we simply use the Compose view and pass down the state into a contained composable? So what we want to quickly look at here is the composable content that is being used inside of our custom view. We can go one step further here now and split out the composable from our content function into its own composable function, allowing us to reuse this both as a composable function and a custom view class. We will then reuse that composable inside of the content composable function. Here, we now have the myCustomView class, which can be inflated into existing Android layouts, along with our myCustomComposable, which can be used within our composable UI. Being able to add this to a layout either via XML or programmatically means that we can abstract out the concepts of Compose from our existing classes. So rather than needing to add a Compose view and then sign a composables directly inside of existing Android classes, we can help to keep a clear line between composable UI and the Android UI toolkit within existing classes. So while the previous code snippets are just simple examples, there are likely to be cases where we are working with more complex custom views that may contain many mutable properties or need to hold some form of internal state. So to begin with, Compose View does not allow us to add any internal properties to a view, other than what might be provided by any contained views. While we could configure and maintain any of these properties as state or as part of the Android class that is using the view, we either might not be in a position to support that, and there could be a lot of code duplication for composables that need more customization. This could easily start to bloat our existing Android classes. There may also be some cases where it makes more sense for that state to be tied to the view, rather than at a global or screen level. Extending from the abstract compose view allows us to alleviate these concerns by giving us a place to hold these properties and have more control over the composable that we are providing. So along with this, the abstract compose view also eases the sharing of composables between both Android classes and composable UI. So while we could share a composable function between a composed view and composable UI, the abstract Android view can help to simplify the reuse of composables between the UI toolkit and composable UI. So for example, we may have a new feature that adds a shiny new composable to our design system. However, we also need to use that new component inside of other existing parts of our app. So while the compose view could be used to achieve this, with the details just mentioned, this could get a little complex. We would need to use our myCustomComposable multiple times inside of multiple compose views to the point where we need some form of reuse to help smoothen our migration. To resolve this, we can split out our composable provided by the content function into a separate composable function, as we saw just now, helping to promote reuse both in our custom view and in our composable UI. If you're still wondering whether you should use the compose view or the abstract compose view, to be honest, the approach really depends on the application in your current setup. But as a general guideline, the way I'm currently thinking of this is the compose view is great for maybe one-off cases when the need arises to switch out existing views for composables, such as a custom view, or we need to house composables for the layout of a parent class, such as view holders and fragments. On the other hand, the abstract compose view is great for when we need to promote reuse of composables between composable UI and the Android UI toolkit. It also helps to abstract configurable information for a component, helping to keep a clear line of responsibilities between composable UI and the Android UI toolkit within existing classes. So now that we've covered use of composables inside of the Android UI toolkit, we're now going to flip things over and move on to how we can use Android view classes inside of composables. So the Android view is a composable function located inside of the Compose UI platform package also. This looks, again, just like any other composable function that we might be utilizing inside of our composable UI. Here, we can see 3 different arguments which the composable function requires. Now, if we're already working with Compose, it's likely that we've already been utilizing the modifier argument when using another composable function. Having this available for this Android View composable allows us to provide modifiers here, just like we would with any other composable. So this also allows us to keep any layout, styling, and other modification properties at that Compose level. Now, this is important things to keep in mind when mixing the lines of Compose with Android views. Maintaining these kind of attributes for your UI will remain smoother if Compose is managing as much of this as possible. If we are mixing this ownership between our composables and our Android views, we start to also blur the clarity of responsibilities for developers who are working with this code. So keeping these concepts at the Compose level will also help your migration moving forward. So you won't need to double back on your work in future when you eventually come to migrating the rest of your screen to Compose. So outside of the modifier, we have the factory and update arguments. These allow us to provide the requirements for creating and managing the corresponding Android View class. Starting with the factory, this is the block where we will provide the Android View class that we wish to use inside of the Android View composable. This factory block will be called a single time on the UI thread when the Android View is initially composed. Because this ensures that the view will only be instantiated a single time, you can also use this block to perform any other related initializations that only need to happen once. When this factory block is called, under the hood, a view holder is used to hold a reference to that view so it could be composed into the UI when it is required. Finally, we have the update block. This is a callback that is triggered once the view has been inflated, meaning that it can be used to set any kind of property data onto that view. So whenever any state changes inside of the Android view, the view will be recomposed. So however, at this point, only the update block will be called to reflect the state change. That factory block will not be called again. So meaning that the view reference that was originally created will be retained. So if you have dynamic content that you need to set on recomposition, this should live inside of the update block so that it can be recomposed when required. So when it comes to utilizing the Android View composable, we mentioned above how there is the potential to start blurring the responsibilities between Compose and other Android classes. So for example, if a developer ends up working in a class that consists mostly of Compose, touching on Android View concepts could add some cognitive overhead, as they would need to start thinking about Compose and the Android UI toolkit. So in some of my own projects, I've been experimenting with splitting out my Android View usage into separate composable functions, allowing me to essentially abstract these UI toolkit references away from my Compose code. This may not be necessary for Android View composables that do not contain a lot of complexity, but is a nice way to add a layer of abstraction should it be needed. We could then access this composable from within our composable UI, and that point of access knows nothing about the fact we are working with an Android view. In most cases, we will be working with individual composable functions anyway, so this will likely be a natural approach that ends up being taken for our composable definitions. So now that we know how to use existing Android view classes inside of composables, I want to take a quick look into a similar concept, which is embedding XML layouts inside of composables using Viewbinding. So I'm not going to cover too much about what Viewbinding is here or how it works, but if you're using Viewbinding currently, you'll have this defined in your project. If you're not using Viewbinding, you'll need to add this before you're doing so. So Viewbinding is where you have an XML layout, and instead of using Kotlin synthetics to access view IDE references, Viewbinding will generate a binding class for you to access those IDs through it that way. So if you are using Viewbinding, you'll also need to add a separate dependency to be able to access the Viewbinding features within composables. With this in place, we can then start using the Android Viewbinding composable. We can see that this looks very similar to the Android View composable that we looked at in the last section. So once the build tools have generated the binding class from your XML layout, you can use the Android Viewbinding composable, providing the inflated view binding reference to the factory of the composable function. Similar to the Android view, we can then use the modifiers and update block to control the look and feel of the content for our composable. This composable then behaves exactly the same way as the Android view, with the only difference being the use of the inflated view binding. So if you're using XML layouts in your project and you want to use those as composables, this is a great way of being able to ditch custom view classes and relying on the XML layouts themselves. So when working with these different views and composables that help you achieve compose interoperability, we're going to be working with some form of state in our application, most likely. When it comes to compose, this is where things can get a bit more interesting. So compose thrives from having a single source of truth, which is even better when achieved through some form of unidirectional data flow. This means that your UI is composed from a single state object, meaning that the state of your UI will only ever be reflected by a single object state, making your compose state more predictable and also more testable. However, this definitely comes across as one of those perfect scenario situations. This would be an ideal world for sure. So in a lot of scenarios, our apps either may never use this kind of approach or might be in situations where we're kind of moving in that direction, but not everywhere in our app where we are using Compose is using that state management system yet. In these situations, we need to work with what we have and take certain approaches to make our state work well with Compose. And there's going to be a couple of scenarios here, and we're going to take a look at two of them. So the first is Compose being the source of truth for our state. So in these scenarios, the composable holds a source of truth, and we may need to communicate that state back to non-composed code. So if non-composable code is kind of managing the overall state of our screen, this is a good scenario to do that. So in order to share composable state with objects that are not being managed by Compose, there is a side effect composable which can be used. And this is a side effect is invoked on every successful recomposition. So in the example shown on screen, we have some form of state that is kept inside of the composable. This is represented by the isEnabled flag, which I've omitted how this is calculated, but essentially represents some form of state. Our composable takes a back dispatcher into its function. And what this composable needs to do is update this listener based on this enabled state. So here, a side effect is being used to update this value. So whenever a successful recomposition occurs for this composable, our external state outside of this composable will be kept in sync with what is inside of the composable. On the flip side, we might also need to work with the state being inside of the view system, something that we are likely currently utilizing in our Android projects. So for example, a lot of Android views hold their own state, which we access when needing such data, such as the text from a text view. In these cases, we can keep the composable state inside of the view system, treating it just like standard view state that we might see elsewhere in our apps. So in this example, we have a custom view which contains a text view, along with a text field composable. The text view is used to show the content that is added into the text field. And because both of these have state, we need this represented within the view and for them both to be kept in sync. So here we use mutable state of for the composable state to ensure it is kept thread safe. This then allows us to keep this view state inside of our Android class and not have to keep it inside of our composable, as well as being able to then reflect this inside of the Android text view that is shown on screen. This gives us the result of reflecting composable state inside of our Android UI toolkit. So regardless of how you're working with state, there are several state-related functionalities that are available for data streams in Compose. So whether your app is currently utilizing live data, flow, or observables, these can be utilized as composable state using the corresponding functions that each of those provides. This means that recomposition can be triggered whenever these data streams are updated. It's worth checking out the corresponding Android X Compose runtime packages for more information on what is available here and how to use them within your apps. So during any of this migration, be it working with state or UI components, there's likely going to be some places where you'll need to call the Android framework from within Compose. There's a couple of talking points here that I wanted to mention before we start to wrap up this talk. So the first is context within Compose. As we are likely aware, we access the context in a lot of places throughout our Android projects. There are also going to be likely points in our Compose projects where we need to do the same. So in these cases, we can access the context using what are known as composition locals. Now, composition locals are used to propagate values from Android framework types to Compose, and this includes things such as configuration, view, and context. So you'll find these within the framework, and they're prefixed with local, so local view, local context, and so on. And then we can then use this for anything that might require a context. So for example, if we need to create an instance of an Android view class that we're going to use within our composable UI, we can use the context like so. And any other thing else that you need the context for, you can access it in this way. Now, before you start doing so, it's worth checking out what utility functions are available in Compose to save you repeating what might already be provided by the framework. So in Compose, there's a string resource composable, which you can provide a string resource ID, and it will fetch the string for you. Under the hood, this is using the local context to access the resources of your project. So it's doing exactly something you could do yourselves, but there's a collection of utility functions available to ease that process for you. So now that we know how to add Android views into our composable UIs, one thing we might need to be aware of is how to adhere to the lifecycle of these additions. So for example, we might be running some process or utilizing some class that needs to be stopped or canceled when our activity or fragment is destroyed. In these cases, we can utilize what are known as side effects in Compose. Now, there are many side effects available in Compose, but in terms of interrupt with Android classes, the disposable effect is an important one. Using disposable effects, we can work with composables that require disposal. So the disposable effect takes a key, which is used to determine when this effect should be run. If we have some class or reference that might be changing, we can provide that as the key so that our disposable effect is run whenever that changes. If that's not the case, then we can simply pass some form of constant value to run the effect only a single time. In the example on the screen, I have a custom view that takes a listener. However, when this composable is decomposed, I want to be sure that we avoid any possible leaks. So for this, I provide an Android view reference as the key for my effect, as my view never changes, so we don't need to worry about this being relaunched. Followed by utilizing the onDispose callback of the disposable effect to tear down my listener. So I am now safe from having leaks from my listener, and by placing this inside of the onDispose callback. So this, however, is a simple example. In some cases, you might need to integrate lifecycle observers to adhere to specific events, like on pause and so on. But in these cases, we would still be able to utilize the disposable side effect to manage our composable and its lifecycle. Again, this is only one example, and I just wanted to introduce this concept. But check out the developer documentation for more information on what side effects are available, and even the Compose samples from Google. There are some nice examples there of how to handle tearing down of specific views, such as maps and so on. So during migration, whenever you're working with state or you're trying to interact with the Android framework, there are likely going to be times when things get tricky or don't quite feel right. And that's okay. Rather than trying to force or wedge things in place, we can follow a simple guideline of flowing data down and passing events up. So to take a simple example, here we need to trigger the launching of an activity when a composable triggers some event. We trigger this activity launching from within our Android UI toolkit code, but trigger this using a callback from within our composable button. So as I mentioned, this is a simple example, but it does demonstrate how we can approach some of these things. The same can be done with state management and other framework interactions. So if in doubt, follow the approach of passing data into composables and flowing events up into the parent. So finally, a lot of composables obtain their theming from theme attributes, taken from the theme that you apply in Compose, or from some form of default if a theme is not set. So it's very likely that you have some form of theming in your application. And the good news is that if you're using the material or app compat themes, there are supporting libraries that allow you to utilize the theming from these inside your composables without needing to recreate and define an entire new Compose theme. So in Compose, we might have a theme defined like so. This wraps our composable content and applies the theme to it. When doing this, we need to provide the attributes that we want to be used in our theme. So this could be colors, shapes, and typography values. The great thing is that using the MDC theme adapter, the composable function will automatically read the theme from the host context and provide them to the material theme. So this means that the material theme in our application that we're currently using can automatically be applied to Compose when using this function. To use the MDC theme adapter, you'll need to add the following dependency. And if you're using an app compat theme, check out the official documentation for notes on a similar library for that use case. So it is possible to customize the values that are used by the MDC theme adapter. And this can be achieved by using the create MDC function to generate the colors, typography, and shape collections. And then you can use these to pass the material theme function once you've done any kind of customization that you need to. And again, check out the documentation for more information on that. Cool. So that's it from my side. If you're looking to learn more about Jetpack Compose, there's obviously the official documentation and the pathways. I run a website called compose.academy, and that has snippets, guides, and blog posts which are focused on Jetpack Compose. So please check that out if you're looking to learn more. We're also currently working on our practical Jetpack Compose book, which will be released later this year. And you can sign up for more information on the website if that is something you will be interested in getting hold of when it's available. Cool. So that's it from me. Thanks again for watching. Thanks for being here. Happy to answer any questions on this or Compose. And yeah, go for it.
Hi, Joe. Thank you so much. That was really, really amazing. So we do have some questions for you. But Sonny, unfortunately, he's having some internet problems, so he couldn't. He was kicked out of StreamYard again. So I'll be asking the questions in the meantime. So our first question is, does Compose to the Android view system work well with the existing app architectures such as MVP, or is there recommended architecture?
Great. Yeah, so Google do recommend or are pushing the MVVM architecture. Doesn't mean you have to use that. Like, it does work well and it's great because a lot of their samples are MVVM, so it makes it helpful to have that as a reference. I know people using Compose of MVI. I haven't seen any MVP examples. I think the difficulty there is it depends how you're managing state. Like, to be honest, I don't think whether you're using MVM, MVI, whatever one makes too much difference. I haven't used MVP, so don't hold me to that. But I think it's mainly about how you manage the state. If you have a single source of truth and how that state's being updated, which I imagine might be more difficult with MVP. So it's probably possible, but probably just a little bit more work to get it right.
Cool. Our next question is, does Jetpack Compose work with data binding in the same way layouts do? Not really sure.
I've never used data binding, but you can't use it with Jetpack Compose. Jetpack Compose doesn't have. It's quite a different concept as well. Like, Jetpack Compose doesn't have the concept of essentially layouts because you're composing the UI. So when you're defining your composables, that's all you have. You don't have like a separate file that references the layout or the content of that. I'm not sure if that answers that, but
I'm sure it does.
Yeah.
Okay. Is there a Git repo that we can see an implementation of using Compose with the classic Android view system discussed in the talk?
Good one. So I don't have one. Maybe that's something. I do have a project that has it in, so maybe that's something I could open source. I think if you go to the official Google Compose samples, they do have some Android view usage. So I can't remember what one. I think it's the Crane app has a map which is using Google Maps, which isn't yet supported by Compose. So they're using that inside of an Android view, and that's a really nice example because they're also handling the life cycle. So we talked about side effects. So that they're using side effects there to manage their life cycle. So that's a good one to check out. I can find a link and post it in the chat.
Cool, thank you. One of our last questions are, what are the best practices to adopt Compose for intermediate developers? So those who don't have so much experience building apps?
So I guess that's a good one. So in terms of Compose adoption, my advice would be to start small and really think of like the simplest places in your app that you can start Compose adoption. So even if you have, I don't know, a button on your screen that is inside of your UI, and using the Compose view to replace that button with a composable button. Even though it might seem like, oh, that's like really simple, like it's just a great way of starting to see how Compose will fit into your existing application. And it's also good for motivation, like seeing something on screen and seeing something build and it work. And yeah, starting small individual components, and then once you've got that initial Compose view in place and that individual component, you can start building it up from there slowly. The state is where it gets complicated. So if you can start with stateless views, that would be good. So maybe buttons that don't change their content dynamically, and then go from there.
Okay, I actually have a question of my own. So with side effects or effects, do you think that's going to be prohibitively difficult for developers to pick up on what it actually does and what it actually means? Or do you think it's such a sort of like not really main use case that it actually will be okay for everyone to use eventually?
Yeah, so I've used them a bit, but I don't know them extensively. They are, personally, I think they are a bit more on the trickier side.
Yeah.
Like at first, I imagine like if you're doing small, simple things, like you might not need them. But as soon as you like, there's I think there's like 8 or 10 different side effects which can be done for different things. So like if you want to trigger something on a recomposition, or if you want to trigger something on a life cycle change, or yeah, I think they'll be worth learning. And the way I discovered them was because I can't remember what I was trying to do. I only wanted to run something once on composition, and I couldn't work out how to do it. And then I came across side effects, and that was what I needed. So I mean, the documentation's good, and there's official documentation for it, and there's also a really good blog post which I can put in the chat as well. It's worth reading. But yeah, I think they'd be worth learning, but I wouldn't say they're needed right away, as it could be a little bit overwhelming.
Yes, I think so too. Okay, Joe, it looks like that's most of our questions. Thank you so much for speaking. It was amazing to have you and Eliza speaking at our meetup. We were so proud that you actually made it, and that we could host you. And just thank you so much from the bottom of our hearts. And we hope that you have a lovely day further. And thank you again.
Thanks for having me. It's been great. Really enjoyed it.
Cool. It looks like Patani is back, so let's join him again. Thank you, Joe. Bye.